your favorite study fetch pup here. Let's chase down the highlights of the Pulse of the Wild, unveiling Belize's living ecosystems. To understand the vibrant landscape of Belize, we must first look at the foundations of natural history. Natural history is the study of the natural world, tracking how organisms develop, interact, and evolve over time. It is essentially the biography of our planet. One of the most effective ways to interpret this history is through ecology, which is the study of ecosystems. Understanding the design and function of these systems is a fundamental concept for anyone looking to appreciate the unique environmental tapestry of this region. At its core, an ecosystem is a self-sustaining and self-regulating natural community where living organisms interact with both one another and their physical environment. Imagine a complex, finely tuned machine where every part has a role to play in keeping the system running without outside help. Within these systems, we look at communities, which are groups of different plant and animal populations living together in a specific area at a specific time. This area is known as their habitat. A habitat isn't just a random location, it is a provider.
It offers the 4 absolute essentials for survival: food, water, shelter, and space. When we examine why certain life thrives in Belize, we have to look at the environment's biotic and abiotic factors. Biotic factors are the living components, such as the prey that animals hunt, the predators that keep populations in check, and even the microscopic bacteria and fungi. Abiotic factors are the non-living elements that set the stage for life, including the tropical sunlight, the intensity of the rainfall, the humidity, and the composition of the soil.
In Belize, the characteristics of the soil, such as how well it drains water or its nutrient content, often determine the boundaries between different ecosystems. A fascinating aspect of a healthy ecosystem is its ability to govern itself through built-in biological controls. These mechanisms prevent any single species from overwhelming the rest and destroying the balance. For instance, grazers and browsers keep plant growth in check, while predators and even parasites ensure that animal populations do not explode and deplete their resources. A healthy ecosystem is one where all these organisms exist in balance. It is also important to realize that ecosystems come in all sizes. An ecosystem can be as small as a single organism with its organs working in cooperation, or as massive as the entire planet. Think of Earth as a giant spaceship carrying all the necessary mechanisms to support life. No ecosystem exists in a vacuum. They are all interconnected through the flow of air and water. What happens in one area is usually felt in another, meaning the health of a broadleaf forest in the mountains is intimately tied to the health of the reefs offshore. By viewing ecosystems as these self-regulating teams, we can better understand how life sustains itself over thousands of years.
To understand the vibrant natural history of Belize, we have to look closely at the building blocks of its environments. At the heart of this study is the distinction between a habitat and a community, 2 concepts that are often used interchangeably but have very specific meanings in ecology. Think of an ecosystem as a grand, self-regulating machine. To understand how that machine works, we first need to look at the space it occupies and the living parts that make it run. A habitat is best described as the physical home of a plant or animal.
It is the specific address where an organism lives. However, a habitat is much more than just a location. It is a life support system that must provide 4 essential elements for survival: food, water, shelter, and space. In the diverse landscape of Belize, a habitat could be the brackish water of a coastal lagoon for a manatee, or the high canopy of a broadleaf forest for a black howler monkey. If any one of those 4 basic needs is missing or compromised, the organism cannot survive there. For instance, a forest might provide plenty of space and shelter, but if a drought eliminates the water source, that area no longer functions as a viable habitat for many of its residents. The habitat represents the abiotic or non-living surroundings, like soil composition and climate, combined with the physical structures that plants and animals need to exist. While the habitat is the where, the community is the who. A community consists of all the different populations of living organisms, plants, animals, fungi, and microbes that inhabit a specific area at the same time. While a population refers to a group of individuals from the same species, A community is the sum of all these groups interacting with one another. The material describes this as being similar to a team. In a healthy Belizean community, no species exists in a vacuum. Instead, they form a complex web of relationships. These interactions are what make an ecosystem self-sustaining and self-regulating. Within these communities, there are built-in biological controls that maintain a delicate balance. Predators keep prey populations from exploding, and grazers or browsers prevent specific plants from overtaking the landscape. Even parasites and diseases play a role in ensuring that no single population dominates the community to the point of collapse.
When we observe a healthy ecosystem, we are seeing a community in perfect balance with its habitat. Every organism is not only working to maximize its own energy collection, but is also contributing to the energy flow of the entire system. Understanding this distinction is vital because while a habitat provides the stage and the resources, the community provides the action and the interaction that keeps the pulse of the wild beating across Belize.
Every living thing in Belize, from the jaguar prowling the broadleaf forest to the parrotfish grazing on the reef, exists within a complex web of influences. To understand how these organisms survive and maintain environmental balance, we have to look at two distinct but intertwined categories: biotic and abiotic factors. These are the building blocks of an organism's environment, determining everything from where a plant can take root to how an animal finds its next meal. Let's start with the abiotic factors, which are the non-living elements that set the stage for life. In a landscape as diverse as Belize, these are powerful forces. Think about the weather and climate. Factors like the intensity of the tropical sun, the cooling effect of the wind, the high humidity, and the rhythm of seasonal rainfall. These are not just background details. They dictate what can grow and where. Then there is the soil. Its composition, nutrient levels, slope, and how well it drains or retains water are the silent architects of the landscape. For instance, the well-drained limestone soils of the foothills support different vegetation than the sandy, salt-influenced soils of the coast. Natural disturbances are also key abiotic factors. Events like hurricanes, seasonal floods, or naturally occurring fires might seem purely destructive, but they are part of the ecosystem's long-term cycle of renewal and change. Now, layer on the biotic factors, the living interactions. This is the dynamic part of the wild, where organisms relate to one another. It includes the prey species that provide energy and the predators that keep those populations in check. It involves grazing and browsing animals that prevent plants from overgrowing, and the competition between different species for limited resources like sunlight or nesting space. We must also consider the hidden world of internal and external parasites, as well as disease-causing bacteria, viruses, and fungi. These act as inbuilt biological controls, ensuring that no single population grows so large that it exhausts its resources and collapses the system. The balance between these factors is incredibly delicate. While natural disturbances are a part of the system's design, human-induced changes often push ecosystems toward permanent disruption. When we discuss clearing forests for permanent development, polluting waterways with chemicals and sediment, or the noise and soil compaction caused by poorly controlled tourism, we are introducing disturbances that put the environment in a category of distress distinct from natural means. These human factors can dismantle parts of the ecosystem, reducing its biodiversity and its ability to collect and process energy effectively. Ultimately, a healthy ecosystem is one where all these living and non-living components are in balance. Species evolve not just to survive individually, but to fit into their specific environment, maximizing the energy flow for the entire community. Whether it is the meager topsoil of a forest floor or the presence of a keystone predator, every factor plays a role in the smooth functioning of Belize's life support systems. When one factor changes, the entire ecosystem must adapt, illustrating just how interconnected these living landscapes truly are. Disturbance is one of the most significant factors in how an ecosystem changes over time, acting as a catalyst for both destruction and regeneration. When we look at the natural history of Belize, we see a landscape shaped by two distinct categories of disturbance: natural events and human-induced activities. Natural disturbances are often caused by abiotic factors, which are the non-living elements of our environment. In a tropical setting like Belize, this frequently takes the form of extreme weather.
Think about the impact of a major hurricane or a massive flood. These events can instantly strip forest canopies, erode riverbanks, and reshape the physical structure of a habitat. While these events seem catastrophic, ecosystems have evolved built-in mechanisms to handle them. Over thousands of years, species have adapted to these cycles, and a healthy ecosystem can often bounce back, eventually reaching a new state of balance. However, the second category, human-induced disturbance, is viewed quite differently by ecologists. Even though humans are living organisms, our ability to dismantle and convert natural landscapes for our own purposes puts our impact in a separate, more concerning class. Unlike a passing storm, human activities often result in long-term or even permanent disruption. For example, when large areas of broadleaf forest are clear-cut for permanent development or wetlands are filled in for construction, the ecosystem isn't just being temporarily altered, its fundamental ability to function is being compromised.
The clearing of land for agriculture, particularly on slopes, can lead to the loss of meager topsoil during heavy rains. In Belize, if a forest growing on shallow soil is cleared and the topsoil washes away, the forest may fail to regenerate entirely. In these cases, we see a dramatic shift, where a diverse broadleaf forest might be replaced by a simpler savanna, permanently changing the biodiversity of the area. This transition highlights the fragile nature of ecosystem boundaries. Soil composition and depth are critical for stability, yet human activities like poorly controlled tourism, pollution, and the damming of waterways can lead to soil compaction and sediment runoff.
These disruptions ripple through the food web. When a habitat is fragmented by human activity, animals face noise pollution and the disturbance of their reproductive cycles. This is particularly evident with mass tourism, where the presence of thousands of people can damage the normal rhythm of nature and frighten wildlife away from their essential territories. Ultimately, the long-term stability of Belize's living ecosystems depends on their ability to collect and process energy. Natural disturbances, while intact, usually allow for a succession of growth that maintains this energy flow.
Human-induced disturbances, by contrast, often remove the very components, the plants, the soil, and the specific species that keep the system self-sustaining. Protecting these systems from permanent alteration is not just a matter of conservation for its own sake. It is about maintaining the life support systems that provide the clean water, air, and resources we all rely on. Understanding this balance is key to ensuring that the pulse of the wild in Belize remains steady for future generations. To understand the health of our planet, we have to look at biodiversity, which is the sum total of every different kind of living thing within an ecosystem. In Belize, biodiversity isn't just a buzzword. It is the engine that drives the entire natural world. You can think of an ecosystem's biodiversity as a high-performance team. Every organism, from the smallest microbe to the largest jaguar, has a specific job to do. When they work together, they maximize the amount of solar energy the system can capture, process, and sustain over time. This collective effort is what allows a forest or a reef to stay healthy and vibrant for thousands of years. The two environments on Earth that boast the highest levels of biodiversity are tropical broadleaf forests and coral reefs, both of which are the crown jewels of Belize's natural heritage. These ecosystems are incredibly efficient at collecting energy because they have so many different players involved in the process. In a broadleaf forest, the layers of the canopy act like a complex solar array, with different species of trees and plants evolved to capture every possible ray of sunlight.
Similarly, on a coral reef, the intricate structures and diverse marine life work in a constant cycle of energy exchange. Because there are so many species filling every available niche, these systems are remarkably resilient. However, if we start to lose species, we face a major problem. A reduction in biodiversity is like removing key players from that team. When species disappear, the ecosystem's ability to collect and process energy is diminished. This can lead to a breaking point where the system can no longer perform its essential functions effectively. We see this contrast when we look at places with low biodiversity, such as deserts or areas of permafrost. Because the abiotic conditions in those places are so extreme, very few species can survive there. With fewer organisms to capture and recycle energy, these systems are much more fragile and less productive. Maintaining maximum biodiversity is essential for a healthy ecosystem because it ensures that if conditions change, there are enough different organisms to adapt and keep the system running.
But when human-induced disturbances like mass tourism or large-scale land clearing begin to dismantle these components, we risk permanent disruption. In Belize, our forests and reefs are more than just beautiful scenery. They are sophisticated biological machines. Protecting the immense variety of life within them is the only way to ensure they continue to capture the energy needed to support all life on Earth, including our own. By keeping the team of life intact, we preserve the very pulse of the wild that keeps these ecosystems functioning at their peak. Everything you see in the Belizean wilderness, from the towering mahogany trees to the silent prowl of a jaguar, is essentially a transformation of starlight. It all begins with the sun. This massive star provides the raw energy that powers almost every biological process on our planet. In Belize's lush ecosystems, this solar energy is first captured by a group of organisms we call producers. These are the plants and algae that perform the miraculous feat of photosynthesis. By taking in carbon dioxide from the air and water from the soil and using sunlight as the catalyst, they produce carbohydrates, which are essentially stored sugars, and release oxygen as a byproduct. This process does more than just feed the plant. It creates the very organic foundation of the entire food web. It is worth noting the beautiful symmetry here, known as gas cycling. While producers are busy making food and releasing oxygen, animals and the plants themselves are participating in respiration, taking in that oxygen and exhaling carbon dioxide. This constant exchange functions as a collaborative system, ensuring that these life-sustaining gases remain available throughout the ecosystem. Once the producers have locked that solar energy into physical matter, the consumers take over. Because animals cannot make their own food from the sun, they must derive their energy by consuming other organisms. We classify these animals based on their position in the energy chain. Primary consumers are the herbivores, such as a white-tailed deer grazing on the edge of a broadleaf forest. They are the first to tap into the energy stored by plants. Moving further up the ladder, we find mid-level and high-level consumers. These are the predators, like a barracuda in the Barrier Reef Lagoon hunting a wrasse, or a powerful jaguar deep in the Maya Mountains stalking its prey. However, moving energy from one level to the next is a remarkably inefficient process. Scientists have observed that every time an energy exchange occurs, whether it is a deer grazing or a hawk consuming a mouse, about 90% of that energy is lost, primarily as heat. Only a meager 10% is actually transferred and stored in the body of the consumer. This fundamental rule explains why the structure of nature is shaped like a pyramid. It requires a massive volume of plants to support a smaller population of herbivores, and it takes an even larger community of those herbivores to support a single top-tier predator. This is the biological reason why high-level predators like the jaguar require such enormous territories to survive. They need a vast landscape of producers and lower-level consumers to ensure they have enough energy to sustain their place at the top. When we look at these connections collectively, we see they are not just simple, isolated chains, but a complex, interrelated food web. Every interaction is a vital exchange of solar energy being passed through the community. Understanding this flow helps us appreciate why every species, from the smallest leaf to the largest cat, is a critical link in maintaining the pulse of Belize's living ecosystems. While the sun provides the energy to start the engine of life, it is the process of nutrient recycling that keeps that engine from seizing up. In the vibrant ecosystems of Belize, from the humid broadleaf forests to the tangled mangroves, nothing is ever truly wasted. When an organism dies, sheds its skin, or drops its leaves, a specialized team known as the recyclers steps in to ensure those essential building blocks return to the system. This team is composed of two main groups, decomposers and scavengers. Decomposers are the microscopic heroes of waste management, primarily consisting of fungi and bacteria. Their job is a vital ecosystem duty, breaking down non-living organic material into its basic component parts. Imagine a massive mahogany tree that has finally fallen in the forest. Without decomposers, that tree would sit there indefinitely, cluttering the forest floor and holding on to all the minerals and nutrients it gathered over a century. However, through the work of fungi and bacteria, assisted by the tropical heat and humidity, the wood begins to rot.
This process turns hard timber back into the rich, dark soil that characterizes a healthy jungle. In the mangroves, this same process turns fallen leaves and sticks into what we call detritus, a nutrient-rich organic material that feeds the smallest inhabitants of the coastal lagoons. Then we have the scavengers, like the ubiquitous vultures known locally in Belize as the John Crow. While many people find these birds unappealing, they perform an essential service by consuming carcasses that would otherwise become breeding grounds for harmful bacteria and disease.
By eating dead animals, scavengers handle the bulk of waste removal, allowing the decomposers to finish the job at a molecular level. The importance of this cycle cannot be overstated. If nutrient recycling were to stop, the world would quickly become an unwholesome and cluttered place. More importantly, it would become starved for nutrients. All the nitrogen, carbon, and minerals required for life would remain locked up in the first organism that absorbed them. Without this continuous loop, the ecosystem would require a massive and impossible input of outside resources to keep producing new life.
Instead, nature follows a circular path where, as the saying goes, we return from dust to dust. Every piece of juicy mango or guava that grows in Belize is nourished by the recycled remains of what came before it. By transforming waste into renewable nutrients, decomposers and scavengers ensure that the pulse of the wild continues to beat, maintaining the balance and long-term health of our planet's life support system. This natural waste management system is so efficient that human technology has yet to find a way to replicate or replace it, making the conservation of these often overlooked organisms essential for our own survival. To truly understand the natural history of Belize, we have to look at the invisible rules that govern how many living things can exist in one place and how they interact. The first of these rules is carrying capacity. This is the maximum number of organisms an ecosystem can support under specific environmental conditions. It is not a fixed number. It fluctuates based on the resources available. For example, a year of plentiful rainfall in the Belizean bush results in lush plant production, which can support high populations of grazers like deer, and in turn, more predators like jaguars.
However, if the next year brings a severe drought, the carrying capacity drops. The ecosystem can no longer support the same numbers, often leading to a natural but harsh die-off across all levels of the food web. When this balance is pushed too far, we face the threat of extinction. While extinction is a natural process, human activity has accelerated it significantly. A sobering example is the stellar sea cow, a massive relative of the manatee. After its discovery in the Arctic, it was hunted to extinction in less than 30 years.
The loss of a single species is tragic, but the loss of a keystone species is catastrophic. Keystone species are organisms that are so central to the web of life that their disappearance triggers a cascade event. Imagine a rare rainforest bee that pollinates 6 different tree species throughout the year. If one of those trees is removed by logging, the bee may lose its food source and go extinct. Without that specific bee to pollinate them, the remaining 5 tree species cannot produce seeds. As the older trees die off with no young generation to replace them, every other animal that relied on those trees for food or shelter also faces extinction.
This chain reaction is why biodiversity is so critical. Every link supports the others. However, nature is also defined by cooperation, which we call symbiosis. These partnerships take several forms. In a mutualistic symbiosis, both organisms work as a team and both benefit, which is vital in competitive environments. Then there are commensal relationships, where one organism benefits while the other is unaffected. We also see parasitism, where one organism thrives at the direct expense of a host. Beyond these physical partnerships, many stationary organisms use antibiosis, producing chemical compounds to defend their states.
These chemical defenses are actually the source of many human antibiotics. All of these interactions together form the food web, a complex map of how solar energy moves from the sun to plants, and eventually through various levels of consumers. By understanding these concepts, we see that an ecosystem isn't just a collection of plants and animals. It is a finely tuned machine where every part, no matter how small, plays a role in maintaining the pulse of the wild.
To understand the living ecosystems of Belize, we must look at the physical stage upon which they are built. Three primary geographic factors act as the architects of this landscape: latitude, soil composition, and landforms. Belize is situated between 15 and 18 degrees north of the equator, placing it in a critical transition zone between subtropical and tropical climatic conditions. This specific location is one of the principal reasons the country can support such a staggering variety of habitats in a relatively small area. While latitude sets the temperature, soil is the most important determinant of vegetation. The story of Belizean soil begins underwater. The country was submerged beneath the sea at least 3 times in its geological history. As a result, much of the foundation is made of limestone, which formed over millions of years from the skeletal remains of sea creatures. These limestone soils are rich in calcium carbonate and are relatively soft. Over millennia, heavy rainfall has pounded this rock, with water trickling into cracks and fissures to carve out the vast network of caves and karst landscapes that define much of the northern and central regions. In contrast to the limestone lowlands, the Maya Mountains dominate the south-central portion of the country. These are the oldest mountains in all of Central America, representing Belize's volcanic beginnings. These mountains cover 1/3 of the country and are composed of Paleozoic rocks and granite. This geological difference is striking. While limestone creates fertile ground for broadleaf forests, the granitic soils of the Maya Mountains are often sandy and nutrient-poor. We see the result of this in the mountain pine ridge, where shallow, acidic soil supports hardy savannas and pine trees rather than dense jungle. The topography of these landforms also dictates the flow of life. In the mountains, steep slopes and high altitudes lead to increased rainfall and cooler temperatures, creating distinct plant communities that cannot exist at sea level. As rivers flow from these heights, they carry eroded minerals down to the lowlands, creating ribbons of rich alluvial soil called gallery forests that cut through the leaner savannas. We must also recognize the fragility of this geography. It can take up to 500 years for nature to create just 1 centimeter of soil, yet human-induced disturbances like deforestation can cause many centimeters of that precious topsoil to wash away during a single flood. With only 16% of Belize's land being naturally suited for agriculture, understanding the relationship between the ancient Maya mountains, the porous limestone bedrock, and the surrounding soils is vital. These physical features do more than just shape the horizon. They dictate the boundaries of every ecosystem, from the highest peak to the coastal mangroves. While factors like latitude and soil composition set the stage for Belize's natural history, it is the dynamic interplay of rainfall and altitude that truly fine-tunes the country's diverse landscape. Belize sits in a vital transition zone between subtropical and tropical climates, and this positioning creates a dramatic gradient in precipitation from north to south. To put this into perspective, the southern region near Punta Gorda receives roughly 4 times as much rain as the northern district of Corozal. This isn't just a matter of how often people need umbrellas. These patterns dictate the very architecture of the ecosystems themselves. Rainfall influences nearly every biological process in the forest, from the height of the canopy to the timing of flowering and fruiting cycles. This variation creates distinct subtypes within a single habitat category. For instance, broadleaf forests remain the most dominant habitat in Belize, yet a broadleaf forest in the rain-drenched south looks and functions differently than one in the drier north. In the north, the duration and intensity of the dry season force plants to adapt to water scarcity, whereas the southern forests are shaped by near-constant moisture.
This differentiation ensures that even within the same ecosystem type, biodiversity can vary wildly depending on the local rain gauge. As we move inland toward the Maya Mountains, altitude begins to play its part. Although Belize does not reach the extreme heights of the Andes or the Himalayas,
As altitude increases, temperatures drop and rainfall tends to hit its highest levels in the country. This creates a challenging but rewarding environment for specialized plant communities. At these higher elevations, the steepness of the slopes and the depth of the soil further dictate what can survive. Slope determines how well the soil drains and influences the structural integrity of the forest canopy. Because of these factors, you will find distinct plant species in the mountain mists that simply cannot exist in the lower coastal plains.
When you combine these varying levels of rainfall and altitude with Belize's unique geology, you get a living mosaic. This includes everything from the expansive broadleaf forests and pine savannas to freshwater wetlands and coastal mangroves. You also see the transition into littoral forests, seagrass beds, and the magnificent coral reefs. Each of these habitats is a result of specific environmental thresholds being met. By understanding how rainfall and altitude differentiate these areas, we gain a deeper appreciation for Belize's living ecosystems. These geographic factors ensure that the pulse of the wild remains vibrant and varied across every square mile of the country.